Hello guys, Happy New Year. This is my first professional video of 2026. Wishing you all a new year of good health, peace, joy and prosperity. New year comes with new taste. In this video, I'm gonna present you a little touch base on the workover and well intervention stuffs. Let's dive in. In here we have a well being shut-in with the well head pressure shown at 600 psi. We're gonna mess around with the measuring units and the pressure regime concepts in a workover well intervention well here. So we have a gas cap from the wellhead down to 4,000 feet TVD. From there downward you have oil. So that's the gas oil contact water depth 4,000 feet TVD. The bottom of the well is 12,000 feet TVD. So the gas has density of 0.6 Sg and the oil has density of 32 degree API. Screenshots. Alright, we have production packer here. Above the production packer is a SSD, which stands for the sleeve sliding door valve, which is installed at 8,200 feet TVD. Alright. On the annulus side, annulus, you have the packer fluid, which is brine, having density of 9.2 ppg from top to the production packer. And the annulus pressure on the gauge shows 0 psi, which means you have no communication between annulus and tubing. You have good zonal isolation at the production packer from above and below. And now the question is, find out the differential pressure across the SSD. The principle to resolve this question is to find out first the pressure inside the tubing at the SSD depth, and then find out the pressure on the annulus also at the same depth SSD, then deduct them together. You get the differential pressure at the SSD between inside and the annulus. So for the tubing, the pressure inside it equals the sum of three values. The first value is this shut-in pressure 600 psi. It acts all the way in all direction from top to the very bottom of the well, 600 psi. So the SSD inside the tubing will see 600 psi. The value number 2 is the hydrostatic pressure of the gas cap. And the value number 3 is hydrostatic pressure of the two vertical depth of the oil inside the tubing. Alright, now let's get to find out each of them. Alright, we find the hydrostatic pressure of the gas. We only got the shut-in pressure 600 psi, so that's no discussion on that one. To find out the pressure in psi, we need to convert from Sg to ppg. So you take 0.6 Sg times 8.33, that's the formula. To convert from Sg to ppg, you get about 5 ppg. Take that, multiply by 0.052, and times 4,000, you get 1,040 psi. That's the hydrostatic pressure of the gas column in the tubing. Next step, you find the hydrostatic pressure of the oil between the gas oil contact depth down to the SSD. Now they give you the density of the oil 32 degree API. So this is another little mess. You got to convert from API degree to ppg. It takes 2 steps to do that. The first step, convert from API to Sg using this formula. Sg equals 141.5 divided by the sum of 131.5 plus API degree. Just plug in the numbers and you get 0.865 Sg. The second step is to convert from Sg to ppg. Same as before, you take that Sg times 8.33 to get ppg. Plug it in the numbers, you get 7.2 ppg. Take that, multiply by 0.052, multiply by the two vertical depth between the gas oil contact at 4,000 down to the SSD at 8,200 feet, you get 1,572 psi. So now you sum up those three values, 600 plus 1,040 plus 1,572, you get 3,212 psi. Now you need to work out the pressure on the annulus across the SSD. It's just simply the hydrostatic pressure of the brine, 9.2 ppg. Alright, apply this formula here, 0.052 times 9.2 times 8,200, you get 3,923 psi. Deduct the P annulus from the P tubing, you get the absolute differential figure of 711 psi. That's how you find the differential pressure across the SSD. And that's how the pressure is acting inside and outside the tubing. Hope you enjoy it. Cheers.